go. All right. So I'm going to go back to my screen share. And I was just explaining, Rachel, as you were getting logged in again, that this lesson was established in cooperation with Boston School Forest. And tonight our purposes are going to look at cause and effect with shadows, changes over time, and data collection. And before we get too far in, I want to start by recognizing that the University of Wisconsin-Stevens Point occupies the lands of the Ho-Chunk and the Menominee people. And if we could please take a moment to acknowledge this honor, acknowledge and honor this ancestral Ho-Chunk and Menominee land and the sacred lands of all Indigenous peoples. And if you're unsure of what land you are coming to us from, there are the maps on the slideshow that are helpful in determining that as well. So the Wisconsin Center for Environmental Ed was created in the 90s to help move people towards sustainable human and natural communities and interactions through engaged, educated, or to engage and educate populations. And the KEEP mission is to focus on increasing energy literacy throughout the state of Wisconsin. And we do this by partnering with K-12 educators, sharing our resources and building partnerships. KEEP is funded by 6 of the state's major utilities, which include Alliant Energy, WPPI Energy, We Energies, WPS, Xcel Energy, and MG&E. And a lot of the lessons that we incorporate energy education into, we also try to meet some of the Wisconsin standards for environmental literacy and sustainability. And these are 7 different standards that are a part of 3 different strands. And the strands for these are Connect, where we try to establish kids' connections to a sense of place and how they impact their place and how their place impacts them. We also look at Explore and try to understand the natural systems and the cultural systems and their interactions together and how they're similar and different. And then Engage, and that would be where we're trying to foster the next stewards of the earth and help students become agents of change. Our workshop goals for this evening is to discover how shadows can be used to learn about cause and effect, changes over time, and data collection. To identify areas where you can integrate shadows or energy, nature, or the outdoors into your curriculum, and to know where you can obtain resources that will help you explore shadows, energy, nature, or the outdoors in your lessons or your programming. And at this time, Jamie's going to put a link in the chat to a Jamboard. Now that you know a little bit about me and KEEP and what our training is going to be for the evening, I would like to know a little bit about you. So if you could go to the Jamboard and on a sticky note, just enter your name, your school or organization that you're joining us from, and your favorite thing to do in the outdoors. And I'm going to switch and share my screen so you can see the results of the Jamboard. So we have Melissa and Ashley, Brooke, and Brooke's from Clintonville and going for walks in the woods. And that's one of my favorite things to do as well. And Ashley likes to stargaze. And it's good to have you all here. Rachel, I know I met you earlier in the fall when we did our Den workshop at Schmeekley. So that's great too. And it does not surprise me that many of us have that common thread of liking to be outdoors when we're at a workshop titled Exploring Energy Outdoors. I'm going to return back to my presentation screen. And we're going to get started. And the first thing that I just want to talk about is to just remind you that while we may enjoy going outdoors, our students enjoy it as well, but they also have some significant benefits that can help them in their education. And I have a link that I'm going to share with you in all the links from our presentation today. But the link shares an article of a study of third grade students. And the students, some of them were outdoors learning biology lessons and the others were indoors. And they had all the same tools, all the same equipment, and everything was taught exactly the same, whether they were indoors or outdoors, but the only thing different was the setting. And they did this study over several months. And one of the things that they found was the students who had learned outside for that short period of time, when they went to their next class, they had fewer distractions, less trouble concentrating, and were able to focus. And so the benefits of being outdoors and getting students outdoors is it can reduce stress, it can improve students' mood, it helps with their moods, it helps with their concentration, and it can also increase engagement in the classroom, which are all things that I think all educators are on board with. When you go outdoors, however, it's really important to make sure that you still need to have kids be accountable for their learning. And so one of the ways that we like to encourage people to hold students accountable is to ask them to be recording their experiences. And one of the ways that is really popular among kids is through a journal. And so we've, at different workshops we've held in person, had teachers create journals so that they could go back and do the same with their students. And the ones that you see in the picture here are journals that are created from cereal boxes, and you just fold that over to make the cover, and you put sheets of paper in, and then kids can decorate them to show their personalities, their thoughts, make it unique and represent who they are. And then they can take it outside anytime you go out exploring and record the information that they need to have from that lesson. The other thing that sometimes comes in handy is if you have a set of clipboards. Occasionally, you're maybe going to take kids out and going to have a lot more data that you want to collect and gather. And if that's the case, a clipboard with a pre-printed sheet, if they have a table they need to fill in, might be easier and cause a little less confusion than the nature journals. And I know I've worked with teachers who then, when they get back to the classroom, they glue in those pages that they used in the field with the clipboards into their nature journal, so they have, their compilation of work from the whole year. So we are going to talk today primarily about how you can use shadows to engage your students in learning outdoors. And the first thing that I'm anxious to know is how much you know about shadows already. So who can explain to me what a shadow is? And you can just, there's only a few of us here, so if you want to unmute and share, that's fine.
That's a really good question. I've never really thought about the definition of a shadow before. I just always knew what it was, but it's basically blocked energy from reaching a particular surface. So it appears as if it's black or has no color.
Yeah, and that's really important for kids to understand, is it's dark, okay, because it's lacking the light, the energy from the light that shines on it. What causes the blocking in a lot of cases? Anybody have any things that they know?
Is it like obstruction of energy waves or visual light?
Yep. Yep, you're obstructing the visual light, and the energy waves, and it's really anything. Any object that is not transparent that you put in between you or between a surface and a light source can cause that shadow to take place. So the shadows always formed on the opposite side of the object as the light is coming from, which those are things that we as adults probably never think about, but fully understand. But it's sometimes important to make sure you point those out to the students that you're working with, because they maybe don't understand that as well. And it's also good to introduce them to those vocabulary words about, opposite and obstruction and things like that. What are some of the variables that affect the size and shape of a shadow? Does anybody know?
The angle of the light source.
Yes, that's a big one, the angle of the light source. Anybody
The
else have
size
any
of the
ideas?
object.
The size of the object. All right, and sometimes the distance between the object and the light source too can have an impact. So when we look at this picture here, what are the objects that are creating the shadows?
The students' bodies.
Yep, the students' bodies. And when we look at the picture, where is what is the light source in this picture?
The sun.
The sun. And where is the sun in relation to the children? Is it coming from behind them or in front of them?
Behind and above.
Yeah, kind of behind and above. And you can see that because if you look at the way, their legs, you see that the shadow is in the same direction as that their legs are going. Whereas if it was coming from the other direction, you would see the shadow to show their knees were together more as they were jumping. So we can learn a lot by looking at shadows. Taking a look at the idea of cause and effect relationships, which is an important thing to discuss when you're talking about science, not just the ELS standards. How can shadows be used to demonstrate a cause and effect relationship? Some questions maybe to help you think about how you could do that with your students would be, is why are we able to see the dock in this picture?
Because of the light source. So
Yeah.
the cause is the lights. The cause is the light source and the effect is the shadow.
Yeah. So the cause is
relationship.
you have the light source, which is the sun in this case. And then you have the person blocking the sun. And then the effect of him being between the light source and the sun is that the shadow is on the dock. And so we can see the dock because the sun is shining on it. If it was night, would we be able to see that dock as well?
No.
No. If it was cloudy, would we still see the dock? Yeah, because there is always some of that radiation that makes it through the clouds and lightens our days. And in most cases, it's not that common where it gets too stormy that you can't see the light during the day. So you'd still see the dock. Would you see the shadow? Yeah, so if it's cloudy, you might not see the shadow, or it might not be as pronounced, or it might be less dark than what we see right now. And so we can use this to show cause and effect relationships. And you can do this with your students outdoors as well as indoors. So the next thing that I would like us to post in the Jamboard, and when you go to the Jamboard, you're going to want to go to the top where they have the little square and they have the numbers. You want to go to slide 2, but I want you to just quick type on the post-it, explain how taking your students outdoors can help them understand the cause and effect relationship, and really get into the idea of why it's better to be outdoors for this than indoors. What are going to be the problems if you try to show this lesson indoors more so than if you went outdoors. So I'm going to jump over to the Jamboard again. And you're just saying, how can taking your students outside help them understand the cause and effect relationship? Oops, I didn't hit share. See, we're kind of slow to add some things. I'm going to just throw a few things out there. When you're in a classroom, okay, so firsthand experience, that's perfect. When you're in a classroom, how are they usually lit? Ah, very good. We see that one. It's better to take your students outside because there's one main source of light, which is the sun, and that's creating the shadows versus the classroom, which has those multiple lights, you know, and a lot of teachers even have extra lights that they plug in different places. And then you might also have that light coming from the window. So that's perfect. You have the natural light, you have humans that are out there, you have shadows, you have from trees, buildings, other things. So there's lots of different ways to explore shadows when you're outdoors. I'm going to return to the presentation. And the next thing and the next layer in the learning is to look at how shadows change throughout the day. And I know that it's something that we probably as adults, again, take for granted. We know that our shadow doesn't look the same all the time, but I know I've been around kids when they're, you know, really excited about how tall they look, or I look so short, you know, and they don't look how they think they're supposed to look in their shadow. And so the lesson that we're really going to highlight here is one called Seeking Shadows. And the goal of it is to try to figure out how shadows change throughout the day. And so in the Jamboard again, I have another question, and this one is explain what you think you could do to investigate how a shadow changes throughout the day with your students. So what's something that you could do outdoors with your students to try to show them what's going on with their shadow throughout the day? So if you go to slide 3 in the slideshow, you can add your thoughts or ideas of how could you look at the way shadows change. So use chalk and outline the shadows throughout the day. Have them take measurements of their shadows at multiple different times throughout the day. Take them outside at different times. Very good. Everybody's on the same wavelength. And that's exactly what we highlight in this activity of seeking shadows. So going back to the slideshow. The Seeking Shadows activity that Keep has created is one where students demonstrate that the sun's position in the sky determines the shadow length and the direction. And I'm not going to read through all of the directions here, but they basically say the exact things that you put up in your Post-it notes, that you want to have a piece of chalk, or in the case of wintertime, and we do have a video on the Keep page that shows Melissa Ruther and Jenny Christopher, two of a staff member and a former staff member who's now with Schmeekly, doing this in the winter, and they used a rope instead of chalk. So they had just kids lay out the rope on the top of the snow or the ground to show where the shadow was, since the chalk wouldn't work. In other situations, people could use a camera, and you could take a picture with your phone or your camera to see what the shadow looks like at different points in the day. And you pick a specific place to stand, and you always have to return to that same exact place, because if you change anything other than where the sun is above you, you don't have the same results. And then every couple hours, or you could even just do it in the morning, at lunchtime, and right before you pack up to leave at the end of the day, you go. But it's ideal to go at least 3 times throughout the day, and the kids would trace their shadows each time. So it's best as a partner activity where they each take turns, and kids love to have their shadow traced. So I know in my experience, we found that you can't just let one be the tracer and one be the person who gets their shadow, that you have to swap and give the other person a chance to do it as well. And then they can record what they notice in their journal, and they can record that by drawing the pictures. They can record that if you bring out a tape measure or ruler, by measuring the height and measuring the width. They might want to describe it with words. You could even have them, make a limerick or some little poem that goes along with their shadow. Sometimes kids really love doing that when you have the long, tall shadows that are stretched out across the schoolyard. And then you're going to ask them to try to explain why their shadow takes place throughout the day. Why is it longer at some points and shorter at some points? And then why would it be useful to know where shadows are going to fall? How is that an important skill to have? And how does that come into play when you're studying other topics in other areas? And one of our participants in our Den workshop this last fall did this lesson with her students not too long ago. And I'm using this picture to share courtesy of her, Cindy Byers at Rochelt Elementary School. But if you look there, you see the nice, tall, stretched out shadows. That was the first time they went out for the day. And then as the day went on, they would see the change in their shadow. So, I forgot to, let me just swap back. Before we go to the, oh no, those were discussion. I can't remember if these were questions or, oh, nope. All right. Before I unveil them, I thought I put questions on there, but I guess I put the answers. So I will ask the questions, my apologies. But what happens throughout the day to the shadow? So if you were out there with your students, what would you expect to see? Or if you look back at the picture of Cindy's shadow, when do you think that one was drawn? The student looks a lot taller in the shadow than in real life.
It'd probably be in the late afternoon where the
So,
sun is on the horizon lower.
okay, so it could be late afternoon when the sun is lower on the horizon.
Or morning, early morning.
Yep, or morning, or first when they come to school, when it's on the horizon. And then how would you expect it to look different in the middle part of the day?
A lot smaller.
Yeah, so it'd be a lot shorter in that middle part of the day when the sun is more overhead, and it just casts the image, just barely down in front of them. What else would change about that shadow as we went throughout the day? In addition to the size.
How dark and light it would be. So like at one point of the day, it would be a darker, like a more pronounced shadow, whereas other parts of the day, it would be lighter shadow.
So that could happen. What else
Probably
should
the
happen?
angle of the shadow.
The angle of the shadow. So the angle at which it comes off of the person. So, the earth is always moving around the sun. And so the shadow's in a different place overhead. It causes the shadow to be different, but also the angle at which we're measuring the shadow would be different as well. Why might somebody want to know where shadows would fall?
They used to use it to tell time back in before they had clocks. But also if you're gardening, you want to know what time of the day your garden's going to get sun.
Yeah, so sometimes when the sun is the highest, you have, the most obstructions in the path of the sun. So that's not, the best time for your plants to get light, and it might be a better time of day when they get light. Or the opposite is sometimes you want to water your plants when it's not beating down and is sunny. So that would help you know that. Any other reasons you might want to know where shadows would fall?
Well, if you're looking at solar energy, the angle of the sun with solar energy, if you have a tree that's on your solar panel, you're not going to be able to use the optimal energy from the sun at that point.
Yeah, so a location for your solar panel, you're going to want to keep it in a place where it's not going to have shadows over it. Can anybody think of any other reasons they might want to know where shadows would fall?
I'll throw one in there for solar gain. Yeah, if inside of a building, if you want the sun to warm up an area inside a home, you might want to make sure that you're building the building so that it's not going to be shaded by trees.
Yeah, so sometimes we want shadows to keep us cool. Other times we want shadows to keep us, or not to be present, so that we can stay warm or keep a building warm. And so shadows are important like that. I know that my spouse always wants to park in the shade in the summer because he doesn't want the car to be so hot when we come back after a long day. And so sometimes we end up walking a lot further so that the car will be cooler and that. And I'm sure many other people have done that too. Does anybody have any questions before we move on? So I'm going to click on the slideshow and just review what we've talked about. When the sun is lower in the sky, the shadows are longer. When it's higher in the sky, the shadows are shorter. The morning and the late afternoons are when the shadows are going to be the longest. And the middle of the day are when the shadows are going to be the shortest. And I didn't put it in one of the bullets here, but that idea that the shadow will track over time and that you can use it. And that would be, to me, another thing that shadows might be good for. I know my spouse's family likes to hunt, and they like me to go walking through the woods to see if I scare any deer up while they're hunting. And I'm not good at all in directions in their part of the woods because I didn't grow up there my whole life knowing where it is. And so my husband always tells me, well, your shadow should be right here. And if you just keep your shadow in that spot the whole time you're walking, you're going to end up where you need to go. And so sometimes when I've been off by myself running on a trail or something and I'm worried that I'm getting lost, I'm like, okay, think about where my shadow is and use that to help keep me going in a straight line or keep me guided in the right way. Similar to how you might use the North Star at night. And then we did already discuss why a person might want to know where their shadow would fall or where a shadow would fall. Now, one thing that is new as of this training that we haven't had in the EEO training before is I thought, if we're going to spend all this time with students outside exploring shadows, tracing their shadow for the day, it might be good to find out who really understands what you've taken away from that. And so I found this picture online first, and then it sparked an idea for me of a simple assessment that I think would be a fun thing for kids to do. You'd likely have to have an iPad or access to some type of camera, a digital camera that students could use, but I would ask them to take a creative picture using a shadow. So if you look at the one on the slideshow, it shows, the person pretending that they're picking up the leaf or pinching the stem of the leaf. And then once they have their picture, they need to explain how they knew or use their knowledge of shadows to create the image. And if they're doing a better job, they're going to talk about how they had to have it just the right distance and at just the right angle so their hand didn't look like a giant hand or like a teeny tiny hand, but that it looked just like the regular size hand that you would want to pick up a leaf. Or maybe the goal of their picture would be to make it look like there was, a little tiny fairy picking up this leaf. And so then they would, look at the angle of the sun, try to have the light positioned high above them and keep it at a good distance so that you can make that teeny tiny fairy hand or the great big giant hand. In addition, a lot of the science standards ask for students to model or diagram things. And that's something that you could also ask them to do is they could, do a rough sketch of the picture that they took, and then they could have to explain where was the sun, what was the angle of the sun, where was the shadow, how big was the object, how big was the shadow, and use some measurements and skills like that to show what they've learned as well. And then in addition, I have a rubric. Can you see the rubric now? Okay. That makes it really easy to see if the kids have met the standard. So if you look at the proficient all the way across, the creative picture, that's more a fun one. It's not something that necessarily ties in with a standard that you might be learning about in science or something else. But in the explanatory paragraph or the model and the diagram, there's all the criteria of what would be proficient for that. And these are all Google documents, so you could download it and tweak it to meet your needs. If you use different words than exemplary, proficient, approaching, not yet, you can change those. But it's a really quick and easy way, at the end of a period that you could engage kids in exploring shadows a little bit more on their own to determine how much they took away. And, the exemplary is always just going above and beyond in their descriptions, whereas the proficient is explaining the locations of the objects, the shadows, how it worked, and then how would it be different if you moved that light source. So if you were using like a headlamp or a flashlight to create it, how would it be different if you moved it straight up above versus having it at an angle? Going back to the slideshow, the one thing I wanted to look at next is what you guys would have for suggestions for additional things that you could do with students outside. So one other one I was going to introduce was just that idea of the opposite of, when you're inside and you have the screens that you put the light behind and the people walk in front and then the shadows are cast like in a shadow theater. You can do the same thing when you're outside. And I always find it interesting when I'm going for a run in the fall and the corn stalks are all up high against the road. And sometimes I look at my shadow and it's like, oh, my form is not very good today. I'm not picking up my feet. But kids can have a fun time acting out or, playing charades or doing something where you're looking at their shadows as well. So at this time, I'm going to ask you to go back into the Jamboard and go to oh, I guess I didn't have you do the how do we know where shadows are going to fall will be useful, but we did discuss that. So here, go to slide 5. What ideas do you have to extend the study of shadows? So what are other things that you think students would have a fun time with outdoors connected to shadows, or things that maybe you've done outdoors or indoors? So have them create a sundial to tell time throughout the day. Yeah, and depending on where you're at, I know a lot of the trails, that go along the rivers or around the lakes, sometimes they have sundials as part of they're just, part of the ambiance there. And so if you have one in your community, that's great to do. The campus here at Stevens Point has one. Oh, take temperatures in the sun and in the natural shadow of a tree or a building and see how that shadow impacts that temperature. I think sometimes it's fun to look at critters and look for critters and see which ones are in the sun versus which ones are in the shadows. Sometimes you can, if you're looking at bugs and insects and things, you can see ones that are definitely trying to stay in the shadows versus ones that are not. Or if you look at other animals and living things. One thing that one of my colleagues shared with me today was that he used to give kids a challenge. And so he'd put a picture and they had to try to find objects that they could put together to make a shadow that looked like that picture. So you could use blocks or rocks or things like that if you're outside to try to engage students in, just that understanding and that scientific thinking about how do I have to have this compared to the angle of the sun or the angle of my light source to be able to, cast this object to look how I want it to look. Going back to the presentation now. Are there any questions before I go on? All right, I have one other resource that I wanted to share that's not directly linked with shadows, but it's one that I think partners very well with the exploration of shadows because it starts to get into that idea of habitat and ecosystems and how do things like shade and sun affect organisms and critters in our environment. And so this is a keep activity. Oh, leapfrog with shadows. Students need to create and only move within the shadows. I love that. That's great too for getting them active because when you go outdoors, sometimes you have to burn that energy a little bit before they can calm down and listen. So very good idea there. But the energy use in an ecosystem is a great activity. It's one of the keep activities where students can use energy tools. You can borrow the Keep Energy Audit Kit to use some of the tools that are in the image on the screen. So the FLIR cameras you can see, and then there's the infrared thermometer and that, where they're looking at the images, and you can see here on the FLIR that the leaves show up as a different color than the grass that are around them, and it's based on temperature. You can look for, evidence of life, if there's different organisms that live in there. Students get really interested in looking at scat that way and determining how recent it has hit the ground by how much heat is picked up by the FLIR cameras. So Keep has energy audit kits that you can check out to do those type of explorations with your students. If it's something that you want to do and you forget to check out the kit and you want to go outside right away, you can use simple tools like just a regular thermometer. You don't have to have the infrared thermometer. You can, we have the anemometers for measuring wind at different locations, but you can take a pinwheel out and you can see how much wind is in a certain area. We have a light meter that you can use, but there's other ways like looking for shadows that you can use to determine how much light is in an area. And basically the idea of this lesson is that you go to about 3 different study sites and kids can explore all these different things, soil moisture too, and maybe looking at, is the soil moisture different when you are in a shaded area versus a sunny area? And that one, we do have a moisture thermometer, not in this kit, but in another activity that we have. But we've also, you just tell kids to dig up some of the dirt and rub it in their fingers. And if it clumps, it's moist. And if it crumbles, it's pretty dry. And so you can look at that and then talk about what types of animals live in those different areas that you've examined. And you can kind of look at what their adaptations are, what their food chain might be, and skills for survival, and based on like how those abiotic or those non-living things impact the living things in their environment. And when you have this presentation sent to you, the link for the Keep activity that has even the printout that I have on the side is all linked there, as well as the link to check out the kits and trunks if you're interested in using it. And I'll tell you, nothing has energized even the college students that I presented to more than those FLIR cameras. Like everybody loves them. And even adults, like this past fall when we did the workshop, we had some of the people using the thermal guns and posing and taking their pictures with it as they were measuring the temperatures outdoors. We had a lot of people who were, our goal was to do the ecosystems, but they're measuring the bike rack and the parking lot and all the different surfaces that you have outside. So it doesn't have to just be connected to nature, but it really can be connected to, does this color surface heat up faster or slower than another colored surface? And that. So it's a great way to get kids interested in learning about science when they maybe don't even realize that that's what they're doing, because they're having so much joy in their lesson. So wrapping it up here, the things that we wanted you to take away is, how can you use shadows to show cause and effect and changes over time? Where can you integrate shadows, energy, nature, or the outdoors into your curriculum? And where can you obtain resources to use to engage students in lessons about energy, nature, and the outdoors? And I'm going to flip over to the Jamboard one more time. And on the last slide, it has those 3 questions. If you could at least answer 1 or 2 of them, if you have great ideas for all 3, we would love to hear them. We have our ideas that we presented, but we know that that's not the only way that students can be engaged in learning, especially outdoors. The world provides us with lots of opportunities. So if you have interesting ideas on how you can do this. Oh, I love that one, through the different seasons. So, finding a place that you could look at the shadow in, the start of the school year and maybe each month of the school year to see how it's different, especially if you stay at the same time of day. And that also gets to the time too, and when the sun rises and when the sun sets, because there's definitely times in the winter where it's barely up and kids are already starting to come to school. The angle of light source, determining the size of the shadow, learning about the weather as well, using keeps, trunks, and kits. So lots of different opportunities that we're hoping you will be able to take back and energize your students with in your classrooms. Do you have any questions before we start to wrap things up? All right, if anybody does and they want to stay around and ask them, you're welcome to. We'll stay on as long as you, or I'll stay on as long as you have any questions. But before anybody leaves, I do ask that you please take an evaluation for us. Keep really values your honest feedback, because our goal is to strengthen the programs that we offer to meet the needs of you and others who work in the schools and with our students as well. So you can either scan the code, or there is a short link, the bit.ly link that you can use to take that. And I believe Jamie was going to drop that link in the chat as well. And then when you get the slideshow tomorrow or later, there are slides after this too that have links to our upcoming professional development on the calendar. Some that we're hoping to add to it in person as the spring goes on, but then some online opportunities as well. There's a link to all the lessons that are in the KEEP activity guides. There's links to the trunks and kits. And I just want to put a heads up that all of a sudden, since about mid-December, these energy kits have been very popular. We've had a lot of requests for them. So if you think you would like to use the energy audit kit, which is the one posted in the case there, or the solar oven or the pedal power, you definitely want to look into going to the website. You click on just that reserve a kit, it'll open the website. You can look at all we have to offer, but you want to get your reservation in sooner than later to make sure it's available when you'd want it. And then these are ways that you can stay connected with us. And you'll also have my email address in the links if you ever have any questions. So, oh, I see that Rachel commented a little in the chat, which I couldn't see when we were on there. Students take nature toys and made their shadows with other students. That is fun. I actually, when you type that in there now, it reminds me of my son. They had to do a project in, I think, 4K or 5K, where they traced their shadow, and then they had to find objects in nature, like to fill it in. Is that what you were referring to? Something like that?
Yeah, we hiked through the school forest and picked up items, and I went in the grass area and did their shadows. Pretty humorous.
Very cool. Oh, and then on the Jamboard in the field, looking at niche zones in a forest, especially taller trees versus shorter trees. And that can be very interesting too. And I feel like anytime you get into the woods, the schoolyard is great. If you can just get kids outdoors, anything outdoors is in general better than what they are learning in the classroom. It provides those opportunities. But yeah, if you get into those different areas where maybe they don't always walk through on their own or with their families, and help them look at that's very engaging for them as well. Is there anything else anybody would like to share or have questions on? All right, well, if you do have a question that you'd like to ask, you're welcome to stay. Otherwise, it's 4:53 and I want to honor your time and not keep you longer than what you have. I know that educators are as busy as ever, and I've heard that this year is not going any easier for anybody than last year yet. So I wish you all well and hope that we can provide some things for you through our kits and trunks and lesson guides that make the rest of this year go a little easier and more smooth for you. Thank you. Oh, I should stop recording.
You did great.